Hello everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to talk a little bit about some of the volatility plugins that are intended to help you find malware and other issues on a Linux system. So I'm going to go through these somewhat in alphabetical order. So the first one I want to talk about is called API hooks. Now, by way of warning, a lot of these volatility plugins take a long time to run. So what I'm going to do is I'm actually going to use the time function in Linux in order to show you how long it takes to run these, but I will pause the video so that you don't have to sit here for many minutes while this runs. Now, just for reference, we have a 2 gigabyte memory image, which is fairly small, and I am running this on an 8-core i7 system with 8 gigs of RAM, running Linux Ubuntu 14.04. So I should get some decent performance. Your mileage may vary, of course. So if you're not familiar with time, it's pretty simple. You just run time, and then you give it your command. So as before, I'll use my alias VPA, and I'll say Linux underscore API hooks, and it will run and do its thing. And here we're just starting to get some results. So we've been running for hours now, and this one script is still not done. You can probably notice that it's a little dark outside. As I warned you, some of these scripts take a long time. In fact, I just interrupted this, and this is all the output we got in 174 minutes. So it really has been going on for quite a while, and it's been operating at essentially 100% CPU. So that's the API hooks check. Some other checks. There is a AF info check, and it will look at the function pointers that relate to network protocols. So if you suspect that someone has done something funny with your network protocols, you can give this one a try. So let's go ahead and have a look at this one. So again, it's Linux check underscore AF info. And this is going to look at those AF network calls. And in this case, it returned a lot quicker and it found nothing. Another check function that is available in volatility is this guy, the creds check. And what does this guy do? This guy will check and see if there are any processes sharing credentials, which could indicate some sort of malware. You know, you've got somebody that is trying to use someone else's credentials. In the Windows world, this is sometimes called a pass the hash or pass the token attack. And we see that we didn't get anything here, indicating that's not going on. You can also check your file operation structures to make sure that some rootkit hasn't been used to modify them. So the command for that is check fop for file operations. We'll let that one run. And this one is now finished in 2.5 minutes. Notice that we didn't find anything, which is not surprising given this particular subject. Incidentally, we do have some other subjects that are coming along later in this course. Uh, our first breach was a pretty simple one, and we will do some work with some more advanced attacks later. And in that case, we would probably come up with some results for some of these. I just wanted to show you some of the functionality of volatility, and then later we'll kind of circle back a little bit and we'll delve a little deeper into some malware. Another thing that you can use is you can look at the interrupt descriptor table, and you're probably familiar with interrupts and what they do. So you can check to make sure that somebody hasn't messed with this interrupt table. Try to redirect people to something malicious. So we'll let that one run. And we see this one runs fairly quickly. In 6 seconds, we were able to get all of the different interrupts on our system, including everyone's favorite int80, which is a system call. And that's a system call that's used in 32-bit Linux and Windows as well. Other checks that you can make. You can check for some inline kernel hooks. Is somebody trying to hook some of those functions? Once again, we had the API hooks check for the userland stuff, and we also have similar checks for the kernel space. So we can say, is somebody trying to hook my kernel functions inline? So I can check my inline kernel like so. And we see that this check completed in just over 3 minutes. And once again, we didn't find anything here because we don't have that particular kind of malware. Another test that we can do is we can check our module list against the list in the system file system. Is someone trying to hide something? Something malicious, of course. You can't really completely hide, because even if you Trojan all of the utilities on a system, there are certain things that have to be stored in various parts of your Linux system. So we'll go ahead and we'll run this check. That one's pretty quick. And then once again, in our case, we didn't have any malware of this type. We can also check our system call table using Linux check syscall. This will iterate over our system call table, and we'll let this one run. This will take just a little bit of time as well. So here we're getting some results, and it's first going to iterate over the 64-bit system calls, and when it's through there, it will go back and iterate over the 32-bit calls as well. So that one finished in a little over 2 minutes. And finally, there's one more check plugin, and this one is called check TTY, and it will simply check and see if there are any hooks for any running TTY or terminal devices. And this one is probably one of the quicker ones at 5.5 seconds. And it's basically saying, nope, everything looks good here. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon.